Hi, I'm Richard Cook. Welcome to Fundamentals of Practical Haskell Programming. First, I'm going to say a few little things about me. I'm primarily a C++ and C# developer, and I have about 17 years industry experience. I'm interested in programming languages, functional programming, and obviously Haskell, and I'm organizer of the Seattle Area Haskell Users Group. I'm also a keen open source maintainer and contributor, and I have contributed fixes to the Glasgow Haskell Compiler, for example. I'm also very interested in machine learning and data analysis. And once upon a time, I was a keen musician, keen guitar player, and I do plan to get back into that at some point in the near future. And you can find me online on my webpage at rcook.org, on GitHub, and occasionally on Twitter. Now, this course is about Haskell. Haskell is a strong, statically typed language with a very expressive type system. It also has non-strict evaluation, and it has a very unique approach to problem solving. But this class is going to emphasize using Haskell for practical problem solving. This course consists of several topics in 3 sections. In the first topic, we'll talk about problems that FP and Haskell can address. Then we'll talk about the functional programming specific ways of approaching these problems. Then we'll talk about how Haskell specifically addresses these types of problems. Then we'll take a look at our first Haskell programs and start to begin an intuition for what they look like. And we'll dig deeper into some issues related to white space and layout. Then we'll use the Glasgow Haskell Compiler's read, evaluate, print loop known as GHCi to explore our Haskell programs, values and types and expressions. And then we'll learn to debug with GHCi. Moving on, we'll dig deeper and we'll start to look at Haskell values and expressions, and specifically functions as values. We'll build an intuition for some of the core concepts. Then we'll look at types, polymorphism, constraints, and how we can add type signatures to our values. And we'll look into sum and product types and Haskell's record syntax. At that point, we'll know enough to tackle type classes, and we'll learn how to make our own instances of existing type classes and how to build our own type classes. Finally, to cap it all off, we'll learn how to extract values from our algebraic data types. At the end of this course, you will have a practical working knowledge of Haskell and enough to start writing your own programs. You'll also know how Haskell can help us solve problems and its particular approach to software engineering. And then you'll also have knowledge of values, expressions, and types in Haskell. This course does have some prerequisites. Firstly, I will assume you have some experience with an object-oriented language, such as C++, Java, C#, Python, etc. And I will be comparing some Haskell language constructs with constructs from those types of languages. This course will also make use of the Haskell stack build tool, and I will provide a video providing instructions for setting up and installing stack on Windows, Linux, and Mac OS. And I'll also assume you have some comfort with the Windows, Linux, or Mac OS command line. At the end of all of this, I hope that you'll be able to start writing Haskell programs, and you'll get a feeling for the expressivity and the strength of Haskell's type system. And I hope you have a lot of fun too. Thank you.